1.3 Vectors in 2 and 3-dimensional Cartesian coordinates. In the introduction to vectors, we discussed vectors without reference to any coordinate system. By working with just the geometric definition of the magnitude and direction of vectors, we were able to define operations such as addition, subtraction, and multiplication by scalars. We also discussed the properties of this operation. Often a coordinate system is helpful because it can be easier to manipulate the coordinates of a vector rather than manipulating its magnitude and direction directly. When we express a vector in a coordinate system, we identify a vector with a list of numbers called coordinates or components that specify the geometry of the vector in terms of the coordinate system. Here we will discuss the standard Cartesian coordinate systems in the plane and in three-dimensional space. 1.3.1 Vectors in the plane. We assume that you are familiar with the standard x and y Cartesian coordinate system in the plane. Each point P in the plane is identified with its x and y components, P which is equal to P1 and P2. To determine the coordinates of a vector A in the plane, the first step is to translate the vector so that its tail is at the origin of the coordinate system. Then the head of the vector will be at some point A1, A2. In the plane, we call A1, A2 the coordinates or the components of the vector A. We often write A is the element of R square to denote that it can be described by two real coordinates. Using the Pythagorean theorem, we can obtain an expression for the magnitude of a vector in terms of its components. Given a vector A which is equal to A1 and A2, the vector is drawn like that in the y-axis. This is written like here, x-axis. So we said it here. Here's A with A1 and A2. Here's A2 and here's A1. So in the figure 1.5, the coordinates of a vector in 2 dimensions. We have discussed about the 2 dimensions.